Hello everyone, welcome to my YouTube channel, and today we are going to study practice set 6.2 of the chapter circle. But before that we need to learn few properties of congruent chords. Based on this we have the next exercise. So the first property, just look at the figure and try to understand. What do we see in the first circle? There are two chords AB and CD, and if you look at the length of the chords, they both show 10 centimeter, which means that these chords are congruent. In the next circle, we see that there are two blue lines which are perpendicular to these two chords, and they are also of the same length. Okay, so what does this property say? It says that congruent chords, if you have two congruent chords, then they are equidistant from the center of the circle, means their distance from the center, if you see the blue colored lines, their distance from the center of the circle will always be equal. Okay, but this distance is the, we are talking about is the perpendicular distance. Next, look at the first circle here now. You see two segments which are perpendicular to the chords, and they both are of equal length 5 centimeter each. So you understand that these two perpendicular segments to the chord are congruent. Yes or no? Yes. Now, so if the two perpendicular distance from the center of a circle to the chords are congruent, then we say that if you see AB and CD, they have been shown in blue color. Yes, so if such is the case, then we say that AB and CD are the congruent chords. So what is this property? This property is opposite of what we studied in the previous one. In the previous one, we had the chords congruent, therefore the perpendicular distance was congruent. Whereas in this one, the perpendicular distance is congruent and therefore the chords are congruent. So we have the property which says the chords of the circle equidistant from the center of a circle are congruent. So the chords which are at equal distance from the center of the circle will be congruent. So if you know these two properties, we can easily proceed with our next exercise. So practice at 6.2. Okay, first sum is radius of a circle is 10 centimeter. There are two chords of length 16 centimeter each. What will be the distance of these chords from the center of the circle? Let us try to observe whatever is given in the question. Okay, so first thing that we have is the radius of a circle. In the given figure, the radius of a circle is OB and OD. Okay, whereas there are two chords. So there are two chords also, AB and CD. These are the two chords which are 16 centimeter each. So we have to find out the distance from the center of the circle, which means that we have to find out the length of OM and ON. But before we proceed, let us describe a figure because the figure has been drawn by us. So we'll describe it. So let us describe, let the center of the circle be O and the segment AB and CD be the congruent chords. So we describe a chords and we describe the center of the circle. Also we say that OM is perpendicular to chord AB as such that M is in between A and B. We also say ON is perpendicular to CD such that N is in between C and D. Because of this, what we say that now MB is equal to half of AB. Why am I writing this? See children, if I try to look at this, okay, what is given to me? AB is given to me, which is 16 centimeter, and OB is given to me, which is 10 centimeter. So if I want to find out OM, okay, if I need to find out what is OM, I need to know what is MB. Okay, I need to know what is MB. So MB, this MB is half of AB, and that's why we explained that there. That MB is half of AB because the perpendicular drawn from the center of the circle to the chord will bisect the chord. And therefore, since MB is half of AB, AB is how much? AB is 16 centimeter. Okay, AB is 16 centimeter and therefore MA will be half into 16, which is 8 centimeter. So we have got the length of MB, which is 8 centimeter. So I have MB 8 centimeter. I have MB which is 8 centimeter. I also have radius of a circle which is 10 centimeters. So radius of a circle which is 10 centimeter. Now can I find out the perpendicular distance of the chord from this? Now can I find this easily? OM. If I want to find out OM, I'll apply the Pythagoras theorem to this triangle. So first I'll say in right angle triangle OMB, OB square is equal to OM square plus OMB square, because OB is the side opposite to 90 degrees, so that will be the hypotenuse. So we substitute the values. OB we have just found out, which is 10 centimeter if you see, and MB is 8 centimeter. So we substitute the values. Now the square of 10 is 100 and the square of 8 is 64, which now, so OM I'll keep alone, OM square, and I'll take 64 on the other side, which will become minus 64, and hence it will give me 36. But I need what is OM. So OM is 6 centimeter. So if OM is 6 centimeter, I need to also find out what is ON. Yes, but OM and ON are the perpendicular distance from the center of the circle to the chords, and the two chords are equal. Okay, the two chords are of length 16 centimeter, which means that these two chords are congruent. So we say that ON is equal to OM because the congruent chords are equidistant from the center of the circle. And if ON is equal to OM, I will say that ON is 6 centimeter because OM is 6 centimeter. So hence, finally we say that the distance of these chords from the center of the circle is 6 centimeter. Let us proceed ahead. In a circle with radius 13 centimeter, so it's given here in the figure itself. So and the two equal chords. So the chords are equal, which is given to us, and the distance is given. Okay, the distance from the center of the circle is 5 centimeter. So we have the distance, we have the hypotenuse. We need to find out the length of the chords. So if I want to find out the length of the chord, first I need to find out what is MB, right? And I'll do that by Pythagoras theorem. But before doing everything, let us describe the figure. We say let the center of the circle be O. AB and CD are the congruent chords, and OM is perpendicular to AB and ON is perpendicular CD. Okay, and then we say in right angle triangle OMB. Okay, OB square, because OB is the side opposite to 90 degrees, so OB square is equal to OM square plus MB square, and we also give the reason Pythagoras theorem. So since OB is 13 centimeter as shown in the figure and OM is 5 centimeter, we just substitute the values and we get 169 is equal to 25 plus MB square. So when 25 goes on the other side, it becomes minus 25, which gives me 144. But we need only MB, so we take the square root, which gives me 12 centimeter. So what we have just found out is the length of MB. Okay, we have got MB, which is 12 centimeter, but I need to find out what is the length of AB, which is the entire chord. So I'll say that MB is half of AB, because AB is the chord, right? So perpendicular drawn from the center of the circle to the chord bisects the chord will be the reason. So MB is 12 centimeter, which we have found out, and half into AB. We have to find out. That's why we don't substitute the value there. So when half will go on this other side, it will become 2 upon 1, and it will give us 12 into 2, which will be 24. So AB is 24 centimeter. But it has been given to us that the chords are congruent. Okay, it's been told to us that the chords are congruent. These are two equal chords. Yes. So if AB is 24 centimeter, if AB is 24 centimeter, CD will also be 24 centimeter. So chord AB is congruent to chord CD given. Therefore, we say that CD is also equal to 24. So we say the length of the chords is 24 centimeter each. Thank you.